Welcome back. In the previous video, we discussed why interpretability matters in machine learning, especially in high stakes and real world applications. Now, in this video, we will explore a very important distinction in machine learning models, which is nothing but black box model versus white box model. Understanding this difference is essential because it directly explains why interpretability is easy for some models and extremely difficult for others. Before comparing models, let's briefly remind ourselves about what a machine learning model is. A machine learning model learns patterns from data and uses those patterns to make predictions or decisions. However, not all models are built in the same way. Some are simple and transparent while others are very complex. This difference in complexity is what leads us to the concept of white box and black box model. A white box model is a model whose internal logic is transparent and understandable to human. We can clearly see how inputs are combined, how decisions are made, and why a particular predictions or decision occurs. Because the reasoning process is visible, white box models are naturally interpretable and easy to explain. Now let's look at some common white box models. Linear regressions shows how each feature contributes to the final output using weights. Logistic regression does the same for classification problem. Decision tree represents the decision as a sequence of simple rules, making them very intuitive. Rule-based system explicitly define logic in human readable form. These models allow us to trace predictions step by step, which makes them ideal for explainability. Let's start with a very common example, linear regression. Imagine we want to predict house price. A linear regression model assigns a weight to each feature. For example, larger house size increases the price. More bedroom increases the price. Greater distance from the city reduces the price. Each factor contributes in a clear mathematical way. We can literally write the equation and see how much each features affect the final price because the reasoning is visible and understandable. Linear regression is considered as a white box model. Now let's look into another white box model, a decision tree. Imagine a bank deciding whether to approve a loan or not. The decision tree works like a flow chart. Is income above a certain amount or age above a certain age? Is credit score is good or not? Is applicant is employed or not? Each decision is made step by step and we can trace exactly why a loan was approved or rejected because the logic flows clear rules that human can read and understand. Decision trees are highly interpretable, like the image as shown in here. In contrast, a white box model is a model whose internal workings are difficult or sometimes impossible for human to interpret directly. Although these models often achieve very high accuracy, their decision process is hidden behind layers of complexity. We see the input and the output, but the reasoning in between is not transparent. Common examples of black box models includes neural network, especially deep neural networks, random forest which combines many decision trees, gradient boosting models which builds models iteratively. These models involve thousands or even millions of parameters, making direct human interpretation extremely difficult. Imagine a system that detects cancer from medical image. A model analyzes thousands of pixels, patterns, shapes and textures. It processes the image through multiple hidden layers and produces a diagnosis. While the prediction may be accurate, even doctor and engineer cannot clearly explain which exact features led to the decision. This lack of transparency is why neural networks are considered as black box model. And another example is a random forest model. It works by combining hundreds or thousands of decision trees. Each tree gives a vote and final decision is based on the majority. While individual trees are interpretable, the combined system becomes too complex for human to fully understand. So even if fraud is detected accurately, explaining the exact reason becomes difficult. The key difference between white box and black box model lies in the trade-off between interpretability and accuracy. White box model are very simpler and more transparent, but many struggle with very complex data. Black box model are powerful and accurate but lack transparency. Choosing between them depends on the application, the risk involved and the need for explanation. So now tell me, which model would you choose? If we are approving a loan or diagnosing a patient, explanations matter more than a slight line in accuracy. Am I right? In such cases, white box models are preferred. But if we are recognizing faces in image or translating languages, black box models are often unavoidable because accuracy is matter there. This is why explainable AI exists to bring transparency to powerful black box model system. Okay, now let me know which model are preferred. Okay, think like high stake decisions when you want to know how do high stake decision, or legal or regulatory requirements when explanations are mandatory. Which model you would choose? Take a time. Yes, white box models are preferred when interpretability is critical. These includes healthcare decisions, financial approvals, legal and regulatory environments, and any scenario where explanation are required by law or ethics. In such cases, a slightly less accurate but explainable model is often better than a highly accurate one. Okay, now when it is a large and complex dataset, image, speech or text dataset has to be analyzed. When accuracy is the main goal, then definitely we can move into a black box model. Black box models are commonly used when dealing with large dataset, unstructured data and high complex patterns. Most importantly, when accuracy is matters. In these cases, accuracy may be the top priority and interpretability is addressed later using explainable AI techniques. This is where explainable AI becomes important. Explainable AI techniques help explaining the predictions of black box model without changing their internal structure. They act as a bridge, allowing us to benefit from the power of black box model while still gaining meaningful explanations. As we come to the end of this video, to summarize what we have learned, let me tell you. White box model allows us to see how decisions are made. Black box model often give better performance but higher reasoning. Understanding both types and knowing when to use them is essential for responsible AI development. In the next video, we will explore global and local interpretability and how explanation can be provided at different levels. Thank you, and I will see you all in the next session.